Alright, this is going to be problem number 4 from our Cal 1 test number 3. And it's wanting us to find all intervals of increasing and decreasing for the function f of x equals x squared times ln x. Alright, so basically to find intervals of increasing and decreasing, we need to take the first derivative. But we also need to know some values to plug in for that. So if we just look at it and see what would make our f of x 0, since that's actually the x squared times ln x, you know that if 0 times anything would make that 0, because 0 squared is 0 times ln x. But if you have the 0 being x for ln x, the ln of 0 actually does not exist. But that's okay. That just tells us that 0 can be a critical value, and also that if we plug in 1 is actually a 0. Even though 1 squared is 1, the ln of 1 is actually 0, so we have 0 times 1, which gives us a 0. Alright, so we know that those values are going to be a critical value. But also one thing to note that is that since you cannot take a negative, the ln of a negative number actually does not exist. That'll tell us that we're actually going to be greater than 0 as far as our intervals for increasing and decreasing. So that'll just narrow it down, because if we had a negative number and we squared it, we would get a positive. But if you have a positive number times something that does not exist, then you do not exist. So that tells us that we're going to be looking for things greater than 0. Alright, so now we just need to actually go through and take the derivative of that function. So our f of x is equal to x squared ln x. Alright, so when we we're going to be using the product rule on that, since we have a multiplication in there. But so basically that's going to be the first times the derivative of the second, and the derivative of ln x is 1 over x, and then it's going to be plus the derivative of the first, which is 2x, times the second. Alright, so there we get x squared over x. Let me go ahead and say f prime of x plus 2x ln x. 1 over x's will cancel, so we have x plus 2x ln x. Alright, so now we go through and set that equal to 0. So we're going to have our x plus 2x ln x equals 0. 2x ln x equals negative x. Ln of x is going to be equal to negative 1 over 2, because our x's cancel out. And then to get x by itself, we raise both sides to the e. So just say e ln x, e to the 1/2. So x is going to be equal to e to the negative 1/2 power. Ooh. And whenever you have exponents or anything like that, if it's negative, that's going to tell you that it's in the denominator. And then anything raised to the 1/2 power is the square root. So these two are actually the same thing. So it just depends on whichever way you want to write it. Personally, it may be, I prefer this one right here as far as writing it. All right, so now, since we found our critical value, we'll go through and actually make a chart of our critical values. Critical value 0 just as a reference point, and like we said before at the start, we're not going to have any negatives. 1 over the square root of e and 1. So now just make you a little number line. Say 0, 1 over radical e, and then 1. And you can go through and plug them into a calculator or whatever, but between these values, just pick something between 0 and e, but there it's going to be negative, and anything greater than that you're going to be positive and positive. So we can say that we are decreasing on the interval from 0, since 0 is not included, since we can't have the ln of 0, so we use just a parentheses instead of a bracket, and that's going to be 1 over radical e, and since that actually makes it 0, 1 over radical e is technically not included as far as a specific value, so we use just a parentheses for that, and then we are increasing from 1 over radical e to, and you can see that the positives just keep on going, so it's going to be to infinity, and since infinity doesn't actually have a number, you use just the parentheses, and just like the same reason you use the open parentheses for the 1 over radical e, and we just found the intervals of increasing and decreasing.